Okay, I want to talk a little bit about increasing and decreasing in our functions and concave up and down and that kind of stuff. So I just made something up. I'm not really overly concerned about how accurate this is or if it's drawn to scale. I just want to give you the rough idea of what's happening here. So notice my curve right here. First of all, this is a local or a relative max. In this little world, this local world that it's living in, it's the highest point. Okay, this one down here is a local minimum. This one it's both a local and an absolute max since the function goes down from there. We had this fantastically animated discussion with the math teachers at lunch yesterday about local versus global, or global or absolute mean the same thing. And we had this huge, anyway, so it was fascinating, and we had a few things that we argued about, but I'm just going to go on what we all agree to be true. Okay, so what's happening here is that my function, you can think of this as like we're on this roller coaster, that's the word I wanted, and we're going up, 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 up till we get to this point, and then here we're not doing anything, and we're just kind of sitting there waiting for the car to keep going, and then we go down, 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 and then we go back up and then back down. Okay, so those places where I was going up are where the function would be increasing. So you'll tell me that this particular function is increasing from negative infinity to -4. Notice I'm just using the x values union, and then it's increasing again from 1 to infinity. So I was using those x values as I talked about that. It's decreasing, oh, I can't spell. Wow. Okay, I'm a terrible speller. I don't care. Okay, so it's decreasing here from -4 to +1. And then it's decreasing again from +8 to infinity. And that's how, did I say 1 to infinity? Oh my goodness, so sorry. Fix that. This is increasing from 1 to 8. My bad. Okay, it is Friday. I am tired. Let's see the next thing. Okay, so the next thing is that we can be concave up, and I like to say concave up like a cup, or concave down like a frown. Okay, and so notice that about here, this curve is making a frowny shape. It's just concave down to somewhere about here. And then it's concave up until somewhere about here, and then it's concave down again. Okay, now these points right here are called points of inflection. This is where it changes concavity. Now the correct way to find them requires calculus. Well, in pre-cal, I'm not teaching you calculus. So what we're going to do for our purposes is we're going to say it's approximately the average of the x values. Okay, so this is not good math. It makes me like cringe to do this, but we're going to say that x is approximately, well, -4 plus 1 gives me -3, divided by 2 is -3/2. 1 plus 8 is 9, divided by 2, so this is x is approximately here 9/2. Okay, I'm saying approximately because I have not done the correct method to get these values. So when we talk about where is it concave up, well, it's concave up between those two inflection points. So from the interval -3/2 to +9/2. And it's concave down from -infinity to a -3/2. So this is where it was concave down like a frown. And then we're going to pick it up again from 9/2 to infinity. So I want to make sure that we understand the concepts of these sorts of things. And notice we did not do this correctly, but for our purposes, I still want you to understand what concavity means and what that looks like. So see how this is concave down. Can you see that down? All right. Go practice. Good luck.